Hello everyone, this is a new video for Age of Entropy. In this video I would like to speak about Java native interface. What is Java native interface? How to identify Java native interface in Android? How dynamic binding for Java native interface works? How to set up Ghidra in order to reverse engineer a native library? And how to reverse engineer a specific method used in a binary we created for a test. So, the first thing here is, what is Java native interface? Well, it's a framework created a long time ago for Java, when it was thought only for PCs, where it made a communication between the virtual machine and any other thing outside of the virtual machine that could be, for example, a native library in the OS or anything else created with other kind of language. It was then ported and it's widely used nowadays in Android, and we'll see how to identify it. How to identify Java native interface in Android. The first thing we have to look for when we are reverse engineering an Android application is the existence of a lib folder in the resources. This lib folder usually has native libraries created with C, C++ or any other language that usually end up being assembled. Yes. Like in this case, we have this libmedium SO. Here you can see in a specific case different folders, each one for a different CPU architecture. This is an interesting detail because sometimes applications are built for a specific architectures, which could mean that maybe it won't work on other kind of architectures. One of the most common examples are emulators that usually work on an x86 or x86-64 architectures, when applications are mainly created for ARM 64 bytes. That's the architecture of most of the devices that are around in the market. So, looking at this lib folder is interesting just to understand if you might or not might have some issue running the application. If we don't see any lib folder, it might mean that the application does not use any native library. In this case, we see one, that is this libmedium SO, and then we have to look for in the Java code, decoded in this case with JADAX GUI, for something related to a static method, a static piece of code, which have a system load library. This method is typically used to insert a native library into the code. In this case, we see the name medium. The system load library method usually adds the lib in the beginning, as we've seen in this case, and the .so at the end. And we can see for each method we want to use in this library, we have a method like if it were an interface without implementation and with the native word. That's important. So how does the dynamic binding works? Well, now we have to move on to the library loaded on Ghidra. Here will see a lot of functions added by the library. This is the decoded libmedium SO. And here we can see we can filter always for Java underscore. In this case, it will filter us all the methods created with dynamic binding. And how the dynamic binding works? Well, it basically, when the library is imported, here the OS somehow checks all the exported functions from the libso and takes the ones with a name that is related to the class that where the dynamic binding goes. In this case, the methods always starts with Java underscore, and then the name matches the name of the package, in this case com.mah.medium, and then the class name support3, with the difference that instead of using the dot, use the underscore, like here in this case for encrypt. Then we can see the underscore and the name of the method as it is in the Java code. Okay, so now let's move to how to set up Ghidra in order to reverse engineer a native library. This is something that we should do only once for each instance of Ghidra, the first time we launch the instance. After that, we can use this configuration in every project we use and every library we import. Here what we are gonna do is importing the headers of JNI in order to make it easier the compilation, the reverse engineering of the native libraries. The first thing we have to do is go into File, Parse C sources. Here we can take any configuration. Here my default is Option C Mac Carbon, but it can be anyone. Save profile to a new name. In this case we can put any name. It doesn't matter. Here in the new configuration we have to remove all these files. And we have to add a file. It's called JNI Ghidra. I will link the repository where you can find this. And then we have to remove these parse options and add the ones that are shown in the repository, like it's here. Then after pasting it, we have to parse the program. Continue. And then we finished with this. Now we'll see how to reverse engineer any method. In this case we'll be working with the method final encrypt. We can see here that final encrypt gets by default in Ghidra 1, 2, 3, 4 parameters that are pointers to allow. We have here a lot of offsets. Yeah, and it's pretty hard to understand. So what we're gonna do here is basically changing the types. Once we already built, I included the JNI headers, retype variables, The first, so here it's something related to JNI and how the interface, the framework works. The first method always is a pointer to a structure called JNI environment. After changing this, we can see here that instead of showing the offsets some to the parent one, we have like the call to get object class, get method ID. Of course, we can change the name to make it more representative. Then the second method would depend on the type of calls we are speaking about. In this case, we are dealing with a static native binding. So it means basically that this method is not associated with an object, with a class. It was associated with a class. So we have to change this parameter or retype it, sorry, to a J class. In this case, I will change also the name. Then the other parameters will depend on what kind of parameters the method should receive. In this case, we see two parameters. One is an object called context of type context, and the other one is a string. So any particular or specific object, when it's received on the Java native interface, has the type JObject. I will rename the variable to context. And in the case of the strings, as is a specific type, it has its own binding that is called JString. So there it is. That is how we reverse engineering a method with Java native interface in Ghidra. If you like this video, please follow, subscribe, and add a comment if you have anything to ask, any question, or if not, let's see you in the next video.